Good morning, everyone. Who would have thought? In 2015, Gradle was booth neighbor at Java 1 with JetBrains, right? And they said, hey, we have this language Kotlin, right? Have you heard about it? And it's also very, very useful for DSLs, right? And that started basically the collaboration between Gradle and Kotlin. And now, 2 years later, sold-out conference with 1,200 people, official language for Android, amazing, right? Amazing run for Kotlin. So we're very excited. So and one thing that is that we have observed in the past when new languages enter the mainstream, one thing that, not in this case, but often in the past was an afterthought, was build infrastructure and tool chain that scales, right? And when this is not the case, there is a lot of disappointment waiting, right? And that's why I think it's very important, right, to think about that early. And we were very excited about the features that are work in progress or already work for Kotlin, and that's what I want to talk about. So when we talk about building Kotlin applications at scale, right? So what most people think, oh, it's build time, right? So let's look at the dimensions of scalability, right? And it's a little bit more multi-dimensional. So there's a dimension of incrementality, right? So the time to rebuild after a small chain, which is different from the time to build, verify whole app from scratch, right? But there are other dimensions of scalability. For example, dealing with multiple repositories, right? This is not a Kotlin-specific problem, but it is a scalability problem. Another area of complexity is managing your build logic, right? And we'll talk about that. And finally, the time to comprehend and correct a build failure. For example, a failing test on CI. Why is the build failing, right? So how can we accelerate that process? So let's start with optimizing incrementality. We use build scans to visualize build results. And that is a feature, a new feature in Gradle. So if you Google for build scans, you can learn all about it. I will use them during the whole presentation. And what we're doing here, we're using as a sample project, we're using the spec project. Who of you has ever heard about the spec project? Yeah. So specification framework written in Kotlin. And when we run the spec project the first time with Gradle, we get this result, right? And you can see total build time. Can you read that in the last row? Total build time, about 30 seconds, right? And now, when we run it the second time, most of you know that feature. Gradle has a feature called Uptodate Checks to optimize incremental builds. So, although you all know it, it's still worthwhile to understand how it works, because we will build upon that knowledge when we talk about other features. So whenever Gradle executes a task, it stores the hashes of the inputs and the outputs of that task. And for a compiled task, the inputs would be class path, source code, compiler version. The output would be the .class files. So and the next time we run the task, Gradle calculates the current inputs and outputs, or the current hashes for the inputs and outputs. And if they are the same compared to the last execution, the task is considered up to date and not executed. So in the case of the spec project now, the execution time is basically just the checking of the inputs and the outputs. It's 500 milliseconds, right? So that's a nice improvement. So you have to make sure that the up-to-dateness for your build is working. So one thing you can easily do, you run the build the first time, and then you run it the second time, and then you check, hey, are all my tasks up to date? And interestingly, for the spec project, in a previous version, this was not the case. We had a situation like this. So some tasks were up to date, and some tasks were not up to date. And the build took quite a bit longer. So why is this the case? We haven't changed anything, right? So with build scans, you can now click at one of the tasks that are not up to date, and it will tell you the reason why it was not up to date. In this case it says the manifest MF of the spec runtimes JVM jar has changed. That's why it's not up to date. And when the jar task is not up to date, other tasks will also be not up to date because it's in their class path, right? So why? What was the case here? Well, in this case, in a manifest file, they added a timestamp, right? And that basically always changed the hash. So Eric, who helped me with that slides, Gradle engineer, he provided a patch for that. And what the patch does is to say, okay, for the CI build, that is actually the release build, create always a new timestamp. For the local build, just have a fixed timestamp, new date.0, and then this task will always be up to date, right? So especially for incrementality, the local builds are the most important one. So there are many situations where byte for byte identity is making up-to-date checking and caching, we talk about that later, inefficient. In this case, we could find a reasonable, handcrafted, specific solution, but Gradle has also introduced an abstraction to work in a generic way with those kind of problems. And we call that input normalization. So, for example, what we do out of the box is runtime class path normalization. So, depending, for example, on which platform you build your jars, the order of the files in the jars is different, right? And we ignore that, right? We say you can, a build is still considered up to date, even if the order of the files in the jar is different, right? And the same is true for the timestamps of the files in the jars. If the content is the same, right, we consider it equal. The other thing you can do is you configure some ignore. Sometimes, you know, or in many cases, you have files like build-info.properties that have no effect on the runtime behavior of your your dependency. So you can say, hey, please ignore that in the context of a runtime class path. So that is one type of normalization that we do to make up-to-date checking and caching more effective. The other thing we're doing, that's a very interesting one. At the moment, it works only for Java, but we will be working on making it also work for Kotlin. It's compile class path normalization. So for the compile class path, we do a little bit more. We normalize the compile class path and just to the public signature of your class path, right? We completely ignore any implementation, any private methods, right, to check whether the compile class path has changed or not. So that means when you change an implementation of a method and I depend on your module, it will not trigger a recompile because implementation change, right? So again, at the moment it works only for Java, but we will also make that work for Kotlin. Then very interesting, I will talk about that later in more detail, is path normalization. That is very important for cacheability. Let's talk about that in 5 minutes. And in the future, we work on more built-in normalizations, like that you can define certain properties, like timestamp properties, should not be taken into consideration. So at the moment, you have to do workarounds like the one on the slide before, but we will provide you better out-of-the-box solutions for that. And finally, we want to make it a full public API that you can define your own normalizations. Okay, so other typical up-to-date issues are when you have custom tasks and your input and outputs are not properly declared. So what happens when you forget to declare an input, for example? What could happen? Any ideas? Please.
Changes don't cause the task to get updated or to be marked as not up to date.
Yes. So that then can lead to reliability issues, right? An input has changed, but it's not part of the up-to-date checking, and the task is considered up-to-date, although it should be re-executed, right? The other issue that we see now and then are stale outputs, right? You write a custom task, and let's say a task that converts XML files into Java files, and someone is removing, let's say, an input file, an XML file, but the Java file that is generated when you don't run a clean build is still there, and then you have stale output. So you need to make sure, right, with your custom task that either you make them work incrementally or you remove the output of that task before you re-execute it, right? So that is a key reason why people still do a clean, right? They do a full, when they have issues like that, developers usually say, oh, you have to do a full clean build, right? And that is not necessary. Just fix those issues and you never have to do a clean. Okay, so the next thing I want to talk about, so we talked about up-to-date builds, right? It's a binary check. Either a task is up to date or out of date. If it's out of date, it gets executed. But Gradle has another part of the up-to-date checking is a feature called incremental tasks. So we help you write incremental tasks. So if something has changed, we give you information to rebuild the output incrementally. And I'll show you an example for that. So when you write a Gradle task, you can declare an argument on incremental task inputs. And then we inject that argument into your Gradle task, and then we tell you, hey, those are the files that are out of date, right? Those are the inputs that have been removed. And you can smartly now rebuild incrementally your output, right? You don't have to figure this out yourself, right? What has changed? Okay, so one very important topic, of course, for any language is incremental compilation. So in the case of Java, Gradle does the incremental compile logic for you. It's not a feature of the Java compiler, right? So we make sure to incrementally recompile everything in a reliable way. In the case of Kotlin, it's a feature of the compiler, right? So that needs to be enabled, and the Gradle Kotlin plugin enables that, right? The other feature that is very cool of the Kotlin compiler that is enabled when you use Kotlin via Gradle is that a compiler daemon is started that lives across builds, that is warmed up, and that has a big impact on the compile performance. Oops. And then the other thing that's pretty cool, so the Kotlin compiler is written as an incremental task in Gradle. So it asks the Gradle API, hey, what files have changed? It does not do its own checking, so that's very efficient. The input is not checked twice, right? So there's a really good integration going on there. Okay, that's all about incrementality. Now let's talk about full and clean builds. So when your inputs and outputs are configured properly, there is no need for a clean build. I don't know the last time when I did a clean build for building Gradle, right? Except for doing some experiments. But you still have builds where you have to rebuild everything because so much has changed, as you're building a new branch, or pull in a lot of changes, or CI builds that have no local state, right? Because they always fire up a new machine. So clean builds are a good approximation for those scenarios, right? The build time of a clean build, even if they're not required for correctness. So the key features for making clean builds very fast is parallel builds and cacheability. Of course, they also help with incremental builds, right? But yeah, obviously. So the feature that is available for parallel execution is to run Gradle with -- parallel or set the property org Gradle parallel to true. With that parallelism, you get project-level parallelism. That means when you have multiple sub-projects in Gradle, they are built in parallel. So it's pretty coarse-grained, but it's still very effective if you have a certain number of modules, right? That works with Kotlin, fine. One reason why it's not enabled by default is it does not prevent misconfiguration. You can do certain things in your Gradle build logic, right, that corrupts basically parallel builds. If you don't do that, it's fine, but this feature doesn't allow us to really prevent that, right? So many people use that in production. We use it in production, but it's something to keep in mind. So when you use that feature for the spec project, right, without parallel, it's kind of on this machine 29 seconds, and with parallel, with 4 processes, it's 20 seconds. So that's a nice performance improvement, right? The thing I'm very excited about that since Gradle 4.1, we have a new feature called the Worker API. And that enables a couple of things. It enables very reliable parallelism and intra-task parallelism, right? And you can choose what isolation level you want when you write custom tasks, whether in process with isolated class loader, or out of process, right, depending on what you're trying to do. It can be used in conjunction with parallel, and just to show you how this works. So you can use it for subtask parallelism. If you have a task that can do things in parallel, with the worker API, you can now efficiently schedule that parallel work, right? And then if you have a situation like this, task 7 is taking a long time, right? You can use the worker API to parallelize that and make your build significantly faster. But even if your task is not doing anything in parallel, still use the worker API, because if task 1 and task 2 use the worker API, they can be executed in parallel, right? So it's much more fine-grained parallelism. Of course, that works together well with subtask parallelism. So what is the status? So whatever you do with the worker API, it's enabled by default, right? So this is parallelism that works out of the box. It's stable and GA for any custom tasks. It used to a certain degree already in the Android Gradle plugin 3.0. For the Gradle core plugin, we hadn't had the bandwidth yet to apply it, so that is still work in progress. The same is true for Kotlin Gradle. But for any kind of custom task, use it, and it will not take too long until this will be used by the core plugins, and I also think by the Kotlin plugin. Okay, so that was parallelism. Next feature is reusing build output. If you think about the Uptodate checking, it's just a form of reusing build output, right? But it is limited to reuse the build output from the last time I run the build on this machine. That is Uptodate checking. The advantage you get from Uptodate checking, and that is pretty unique. I don't know any other build system that models input and outputs that offer you that, is that it enables you to do incremental tasks, right? Because it exactly tells you not something has changed, but also what has changed, right? So, and we have now added another layer of reusing build output on top of the Uptodate checking. That is the build cache, and that allows you to use any build output from any time, anywhere, right? And this is how it works. So whenever you have an out-of-date scenario, right? Gradle has already calculated the hashes, right, for the inputs and outputs, and it now, in this case, will only use the inputs, and it calculates the key out of the hashes for the inputs, right? And then it asks the build cache, do you have an output for that key, right? If not, it will execute the task and store the output in the cache together with the key, and then if there is a match, the output will be downloaded from the cache, and it will not be built locally, right? And there are usually there are two types of caches, right? So Gradle comes out of the box with a local build cache, right? And a local build cache is very valuable, although you will not share output between different developers. Imagine you switch a lot between branches, right? Branch A, branch B, you build branch B, you go back to branch A. All the build output from the previous builds is preserved, depending on how much storage space you allocate to the cache, but you get the idea. So, what we usually recommend is that the developers, they use the local cache, and they write to the local cache, obviously, but for the shared cache, right, they're in a read-only relationship. And in the CI builds, they read and write to the shared cache, so that you have controlled environments for the shared cache. It's completely configurable, but that's usually the setup that we recommend, right? And I will show you a couple of examples. One second. I need to enable mirroring. So, okay. So this is when I built. Now I need to. This is when I built Gradle. This is the Gradle build itself, right? We built Gradle with Gradle, obviously, and now let's explore the. Let's remove this guy here. So this build, maybe let's go here first. This build took 1 minute and 48 seconds, right? So it was a build from scratch. Before I executed a build, I did a clean, right? So, and what you can see is nothing was retrieved from the cache and nothing was up to date, right? So it took 1 minute and 48 seconds. Now, when I do the same build with the remote cache, and you can see this here, right? I disabled the local cache for this example. I only was using the remote cache. What you can see now is the execution time went down to 30 seconds, right? Despite the fact that I was working from home and our cache is on an Amazon machine, if I were in an internet with a much faster network, would be even much faster, obviously, right? And there's some interesting things you can see. This task here, patch external modules, right, took 10 seconds, right? So when we look at this, right, just downloading it from the cache took 9 seconds. So that was borderline. If you compare this, how long it takes to building it locally was 21 seconds. But you can see, if I had been working from a hotel room, the cache would have been slower than building it locally, right? But usually, when you have a good network connection, it's very effective. And here's another build where I built everything from the local cache, right? So you can see build cache, right? The local cache was enabled and everything was already stored in the local cache. And now we're talking about a build that took 1 minute and 50 seconds, now takes 9 seconds, right? So the cache is pretty amazing. So one thing to keep in mind, not every task makes sense to cache, right? So we can go here to all the tasks that were not cached, and let's order them according to, just look at them, right? So what you can see is the typical tasks that were not cached are copy tasks, like process resources, or even the jar task is not cached, because when we get the classes from the cache, archiving them in a jar is locally faster, it's just input-output, right, than downloading it. So you can override all this behavior, but out of the box, all tasks that are just input-output, we usually don't cache, right? You can reconfigure that, but that's the default behavior. So don't wonder if you use the cache that some tasks are not cached. That is intentionally, right? Okay. Let's continue. So one important thing to remember, the tasks need to opt in to be cached. So there's no risk in starting to use the cache. Tasks, let's say, that are not properly configured will not be cached. They have to say, hey, I'm cacheable, right? So let's say you're using an old Gradle community plugin from 3 years ago, those tasks will not be cached, right? And then you can look at the build scans to see, hey, what tasks are not cached, what work you need to invest to make them cacheable. One key thing you have to do to make the cache effective is relocatability. So if you have a task that has, that just says, hey, I have those inputs, this directory, Gradle by default uses the absolute path to calculate the key. And you can imagine if that works fine in your local cache, but if you share that cache via the remote cache, the cache key is now dependent on the absolute path of the file. And that means your build will be very reliable, but your cache will not be very effective, right? Because other people have other absolute paths for their sources, and so there's never a cache hit. And we provide you a very powerful API to describe relocatability, to say, hey, for those inputs, only take the path relative to the project directory, or for those inputs, only take the names, right? So, but that's something you need to configure properly. There are tools out there, for example, some language compilers that put absolute path in the binaries to help with incremental compile. So you have to do a lot of input normalization to make effective caching of those, right? So if you want to learn more about using the build cache, how to configure inputs and outputs, that is also very helpful with up-to-date builds. There's a really, really excellent in-depth guide at guides.gradle.org using the build cache. I can strongly recommend that. So now, a little bit of a downer or an upper, depending on your personality. So where are we with the build cache support? So all your custom tasks, cacheable if you configure them properly, no problem. Java, Groovy, Scala toolchains are cacheable. So now Android and Kotlin. This is a little bit, we're not quite there yet. So the Android-specific task will be cacheable soon. The 3.0 was released. There's still a little bit of work left. If you want to try it out, we're offering a Gradle plugin that adds the missing configuration to the Gradle Android plugin. It's a very temporary thing, just if you want to try it out. We expect it to be fixed in the next versions of the Gradle Android plugin very soon, right? So for Kotlin, we're working actively on making the Kotlin task cacheable, which means mostly relocatable, right? So have an eye on the next releases of the Gradle Kotlin toolchain, and we're pretty confident that this will be available soon. And just ask the Kotlin folks about more details about that. But it's all clear what needs to be done, so that will be available soon, and it's a huge accelerator for your build times. So this is from the Gradle build, from the Gradle CI builds, right? This is the average improvement we get from using the cache on CI. It's pretty amazing, right? So, and one thing I want to mention here is a Gradle Enterprise. So Gradle comes with a local build, with a local cache out of the box, but and it provides an API to integrate any remote cache backend, right? So you can do whatever you want. Gradle Enterprise provides you such a cache backend with a lot of smartness when you have multiple location and replication between multiple locations. So if you're interested in the cache, definitely check out Gradle Enterprise, right? Where you also have self-hosted build scans and a lot of other really, really powerful features to have an efficient build infrastructure. So optimizing clean builds, use Parallel and the Worker API, use the build cache and scan to optimize your cacheability, and use the daemon, although that is now enabled by default, so you should be using it anyhow, unless you explicitly disable it. Okay, so now, next topic, maintaining build logic. And how can Kotlin help with that, Rodrigo? So Rodrigo is the lead of the Kotlin Gradle DSL project, and will tell us more about how Kotlin helps us with complex build logic.
Yeah, thanks, Hans. Hello, KotlinConf. Are we having fun? Yes, we are. So, what if we could leverage, all the great work JetBrains put, into the Kotlin language and into these great IDEs, right, that we have, and make altering build scripts, configuring build scripts, altering Gradle plugins much easier, right? So if we had the same level, right, of auto-completion, content assist that we are used to when we work on our production code, right? Quick documentation, navigation to sources, right? These are features that we rely on, right, these days, right? That's the bar where things are at. And refactoring and all that, right? There's a performance aspect of a language like Kotlin, right? Being a statically typed language using static dispatching compared to a language like Groovy, which is dynamically dispatched. While Groovy, it's very good at dispatching, it's very fast, there's still room for improvement with a statically typed language, right? But how does that work in practice, right? Will it blend? We'll see. So we hope the live God demos are pleased today. Yes, I think they are. So this is a very simple, right? The quintessential demo, right? Like the hello world demo. And right now, this is not configured. So I have a Kotlin application that I want to automate the build for, right, using Kotlin. So you can see here, I cannot really do anything here because this is not configured yet. It's just an empty build. And this is the layout of a simple Gradle project. And now I have this build Gradle KTS script in the root of my project. So KTS is the magic word here. It means Kotlin scripts. So now this Gradle build script is actually authored in Kotlin, right? So let's see how that works. So I want to automate the build of a Kotlin application. So the way we do, we organize build logic in Gradle, the way we reuse build logic is by reusing these pieces of functionality called plugins, right? So knowing that, I'm going to see if there's anything for me about plugins, right? So sure enough, there's a plugins block here. And right, all the usual things that would expect to work with my IDE, they just work, right? I can get quick documentation for everything for the plugins block, which is not very useful at this moment, right? But we'll see. So I want to build a Kotlin application. So maybe there's something for me right there when I say Kotlin. I can see that I can create a Kotlin dependency, right? And let's see if that's what I need. Yeah, so that will apply a Kotlin plugin module, right? The Kotlin plugin is separated in several different sub-plugins, as they are called, like the JVM, the JS, the different outputs, the native, right? So in this case, I want the Kotlin JVM because I want to deploy this application to the JVM. So maybe I could just copy this. Yes, I could. And let's see. Cool. So at this point, I'm going to just refresh the project to see if I get anything. Yeah. Now I can build my project, right, because I have the Kotlin plugin that configures all the things for me. All right. So let's just take a look at the whole plugin for a while. So the next thing I want to do, right, is to configure my application. So I want Gradle to actually know this is an application that can be run from the command line. So what I do is I'll just say application, and maybe there's something for me there, Gradle. Sure enough, right? So the application plugin is the built-in Gradle plugin, and there's a guide. Maybe, oh, yeah. It would work, right, if I had a connection. But I won't try to bring my connection with a cell phone. That's only for pros. So I just carry on. I hope you trust me. Oops. So sometimes you see the editor going in red, but that's because all the class path resolution is asynchronous, right? It happens behind the scenes, so Kotlin sometimes might get an in-between state as I'm editing, but that's all good. So if we had seen the documentation, we would know, right, that I need to configure the application plugin. And that's what I'm going to do, right? So once I have the application plugin applied, I get the ability to configure the application plugin via the application block, right? So we can see that the application block configures the application project convention, right? A project convention is a way for a plugin to capture data from the user, right? To model some configuration. So if we want to know, right, all the things I can do here, we can use the Kotlin receiver selector, right, and see, oh, the application, I can configure the main class name, and again, right, we can see the documentation for all the things we might want to see. And yeah, I need to configure the main class name. And at this point, right, we don't need this anymore. Let's just clean it up a bit. And I know that the name of my application is Hello World KT, right? And that's it. So if we are in doubt that this is the real thing, or right, you can always go to the sources, right? You can just navigate all the way through to the JDK and back, right? And that's good enough. So now, let's see if I can run the application. Maybe I can. So I'm going to reload the application. And now I can see the run there. Oh. Yeah. So Hello World KT was not found. And the reason is we had a compilation error before, right? Because the println is unresolved, right? Why that is? Oh, I have to depend on the Kotlin standard library, right? If I want to have all those Kotlin functions, I need to declare a dependency. So declaring dependencies, right? And then I need to declare a dependency on something that Gradle calls a configuration. So dependencies are grouped in configurations, right? And for this particular case, I want to say that the implementation of my application depends on the Kotlin standard libraries, right? So, and again, there are a few like helper methods that we provide out of the box to make configuring Kotlin applications easier. So just like we have a Kotlin dependency or plugin builder, right? We also have a Kotlin dependency builder. And then I can say, I want the Kotlin standard lib. Right? Maybe this will work now. Yeah. Again, Gradle is very helpful. I cannot resolve, right, the standard lib yet because there are no repositories. I just hope this will work offline. So repositories, again, I can just start saying repositories and get all the code completion, right? And let's just use, let's say, JCenter. Let's see. Yeah, and it works. Cool. Thanks. Yeah. I mean, yeah, big shout out to JetBrains that made this all possible. So let me just show you some things you might want to do here and how we actually use the Kotlin language to our advantage, right, to make writing these build scripts easier. So a very common thing you might want to do, right, in your builds when you're automating, right, your tasks is to create like custom tasks, right? You might want to create a task to just output some file or do some munging of data. So I'm going to just create a simple task here to just bring some greeting, right, to show the things we're using, the features we're taking advantage of Kotlin here. So let's say I'm going to just say greet, right? So do you know what's going on here? Can anyone tell me what Kotlin feature we're using here? Yeah? Back there? Yeah, so here we're using you know, the ability to overload the invoke operator for the strings. So actually, if you go to you can actually navigate to the implementation, and then you can learn all about those tricks. But Kotlin lets us overload, you know, the invocation of strings, which is very handy to create a DSL like this, right? So now I'm in a task here, and I can configure, right? Since I didn't declare a type for the task, it's just an arbitrary task. I can do things like do last, right, to just execute some action when my task executes. So let's say I want to print a message. I want to print a greeting, right? But I want this greeting to be actually provided by the user running the build. So I want to take some configuration from the user. And for this scenario, I'm going to use a project property. So Gradle allows users to configure project properties, as we saw before, right? And we do that by using another very cool Kotlin feature called property delegates, right? Property delegation. So I'm going to say, I want the user to use a project property to tell me the greeting. So once I do that, right, I'm binding this name, greeting, to a project property that is stored in Gradle, right, by Gradle. And if we take a look at what the type of this thing is, it's just anything, and it's nullable, because the property might not be there, right, because the user might not configure the property. So your code has to be ready to handle that. So let's say we want to be friendly to the user, and then we're going to use the Elvis operator, right? Who doesn't like Elvis? And say, oh, please tell me what to say. We don't have AI yet on this version. Maybe in the future we can integrate that. But so once we have that set up, right, now we can actually execute a Gradle task, and it's called greet, right? Yeah, I didn't set any property, so it just says, tell me what to say. And let's try again, this time with feeling. And there you go. So that's what I had to you today, for you today, guys. So if you want to know more, please go to the Kotlin DSL website, and we have starting guides and more information for you. Thank you.
Okay. Oh, there's one more slide. Hmm? Oh, yeah.
Sorry, so you're excused from clapping when I leave because I forgot that I had one more slide. Thank you very much. So moving forward, right? So everything I showed just now is available today on the very latest Gradle release, Gradle 4.3, right? But moving forward, we want to improve the experience. So the first thing we need to do is to improve the way we handle plugins, right? Because we need to know exactly which dependencies, all the dependency graph for plugins, so we can actually generate all the nice extension methods for Kotlin to allow a good authoring experience in the editor, right? And that will be coming soon. We want to improve configuration for extensions. So I showed you how to configure like the application convention extension, right? But many plugins have like nested extensions. So Gradle extensions can be extended themselves, right? The Gradle model is really flexible and very dynamic. And that poses a very interesting challenge to integrate with a statically typed language like Kotlin. We want to make writing plugins in Kotlin much easier than it is today. It's already very convenient. We provide a plugin called Kotlin-DSL. So if you're writing plugins in Kotlin, you want to check that out because it lets you reuse all the goodness of the Kotlin DSL in your own plugins, right? And of course, we need to vastly improve documentation. We are very aware that we need to do that, and that's something we will be focusing on for the 1.0 release next year. So again, thank you very much, guys.
Excellent. Thank you. OK, so wrapping down, not Kotlin specific, but one of the big scalability challenges we see in enterprises, right, is dealing with multiple repositories. So Gradle provides some really powerful functionality to deal with multiple repositories. One is called Composite builds, where you can take repositories that have binary dependencies, you can build them together, right, and they are built from source, right, if you want so. A new feature that is just made it into master is external source dependencies that you can treat Git URLs as dependencies, and we retrieve them and build them locally. The other thing that is coming to help with those scenarios is dependency locking, when you use dynamic dependencies to still have reproducible and reliable builds. That's planned for 5, and variant-aware dependency management. That is already in master, where you can use any kind of additional dimensions for binary dependency resolution. So let's assume, I'm not saying that this is going to happen, but let's assume Kotlin 2.0 will not be binary backwards compatible, right, to 1.0. Then you could define the Kotlin 1x and 2x as a dimension of binary dependencies, and Gradle would automatically retrieve the right dependencies that are for 2.0 or for 1.0 or for 1.x, right? I hope this is not going to happen, but just wanted to mention it. Then at least you have a friend here. So correcting build failures, yeah, one really nice feature is, why did my build succeed locally and let's say failed on CI? So you can compare build scans. That is very powerful. You can say, hey, same configuration, same platform, are they using the same dependencies, right? So just to let you know. And yeah, so if you want to learn more, Gradle.com build cache, Gradle.com build scans, look at the Kotlin DSL project with, yes, there's still a lot of work to do with the documentation, but there is already tons of samples out there, right? And there's a guide for how to build Kotlin JVM libraries with Gradle. And follow us on Twitter. Thank you very much.